Today we'll talk about properties of implications. So an implication is nothing but this statement: P implies Q. So it has two variables, P and Q, okay, and not P is nothing but it's a negation of P, not Q is negation of statement Q. So using these we'll construct some more implications similar to P implies Q, and these implications are known as the properties of implications. Okay, they are the same statement, however the variable combination would be different for those implications. So let's see what those implications are. Let me remove this first. Suppose that we have variable P, we have not P, which is negation of P, we have not Q and Q. So the statement Q implies P is called converse of implication P implies Q. It's the same thing, but the form is different. So converse is another form of the conditional statement P implies Q. Okay, so this is Q implies P is a converse, and not P implies not Q. Such a statement is called inverse of P implies Q. This is an inverse statement. This is an inverse, and the third statement is not Q implies not P. Okay, this is known as contrapositive. C-O-N-T-R-A positive. So I think I got it correct. So these are the three properties of implications, various form of implications. Now the interesting thing is that some of them are logically equivalent, and you can easily prove that using a truth table. So we need to construct truth table and see which one of these implications are similar or equivalent. Okay, and once again I need to erase this, and it's done. So we'll make a truth table that consists of all the variables, all columns, and there will be 4 rows because we have only 2 variables, P and Q. So there will be only 4 rows. So let's draw the table. First P, and then we have Q, then we have not P. We'll take everything that appear in the logical equivalence, the prepositional statement. All variables will list here, and no matter how many variables we have for columns, still we have 4 columns, 4 rows, because there are only primary variable is only 2. I hope I didn't confuse you, but let me show you what I mean. So P implies Q is one of the statement. Q implies P is another statement, and this is my table header, and this is my table. So first we enter true, and then true, false, false, you can see the pattern. We have already seen this table in one of my previous video. So this is true, false. This is a pattern like true, true, false, false, and then true, false, true, false. This is a pattern for two variable. And then the negation is quite opposite of P. Negation of P is false, false, true, true, and the negation of not Q is opposite of Q, which is false, true, false, true. And now we are ready to write the truth value of P implies Q. With P implies Q, when P is true, Q is true, the statement is true. When P is true, Q is false, the statement is false. This is the only case when it is false. P is false, Q is true, the statement is true. P is false, Q is false, the entire statement is true. Q implies P. Let's see Q implies P. So Q implies P is nothing but true and true is true, and Q is false, P is true is also true. Q is true, P is false, This is the only case when it is false, and then the last one is true. So we see that these two are not equivalent. Let's draw another one. This time we'll use contrapositive. Not Q implies not P. This is contrapositive. Okay, so all we need to do is change the value of this and see if it is equivalent to P implies Q. Okay, we need to find the truth value of contrapositive, which is not Q implies not P, and see if it is logically equivalent to P implies Q. So not Q is false and not P is false, which means the statement is true. Not Q is true and not P is false. This means this is false. Not Q is false, not P is true, this is true. Not Q is true, not P is false, statement is true. So we see that the statement P implies Q is equivalent to statement not Q implies not P, which means P implies Q is logically equivalent to not Q implies not P, which is contrapositive. This is the statement not Q implies P is nothing but contrapositive. So there is another set of preposition, another implication, which is also a logical equivalence, and let me write it down. Let me remove this and write down the second logical equivalence. So Q implies P is the inverse of P implies Q, is logically equivalent to not P implies not Q. Okay, so whether this is logically equivalent is to prove. We need to prove this using a truth table, and I leave this as an exercise for you. And the solution for this question will be posted in a next video. I'll make another video in which I will prove the logical equivalence of this statement. But before that, I would like you to try this on your own and see if you get the result. I hope you liked the video. Thank you very much for watching.